So good afternoon. Here you can see the agenda for the class today. This is for Wednesday, October the 7th. We're going to continue to talk about water quality indicators, oligotrophic and eutrophic lakes, and eutrophication, areas of and zones of lakes. So you can see them listed there. There's 6 of them. Spring and fall turnover and that sort of thing will probably be tomorrow's class. So you can kind of see what we're going to be doing. So in front of you, you have, you used to have, sorry about that. In front of you, you have the indicators for good quality water kind of described below. So the first box is dissolved oxygen levels. The second box is coliform bacteria. The third is thermal energy. The fourth is nitrates and phosphate levels. The fifth is the BOD number. And the sixth is the quality and, the amount, variety, and numbers of invertebrates. So in the next little bit, you're going to see 4 different that are trying to get at an understanding of water quality and just the different factors that go with that. So in front of you here, you see slide number 1. And probably the biggest conclusion that can be made here is that dissolved oxygen levels can change even in a 24-hour period. In the first picture here, you see a daytime scenario, and you see plants making lots and lots of oxygen that's going to end up in the water. And so we would have a higher dissolved oxygen water during the day. And then at night, the plants shut down, they don't make oxygen, and it turns into a time where maybe dissolved oxygen levels start to actually decrease a little bit at nighttime. In this slide, you're going to probably notice 3 different things, and probably one of the biggest things to take note of is the idea that when biological oxygen demand goes up due to more bacteria in the water, dissolved oxygen levels almost certainly will go down. And so you can see the different lines that happen. So in this case, the bacteria are increasing in number because of sewage that's being put into the water. Bacteria are coming to decompose that sewage, and so their demand for oxygen goes way up, which means there's less dissolved oxygen for other things. If you follow this kind of downstream a little bit, you'll notice that over time and distance, things will return to normal, and probably for 2 reasons. Number one, the bacteria have done a good job decomposing the sewage. Now the sewage isn't there. That means the bacteria die. They no longer demand the oxygen, and so the dissolved oxygen levels will start going up. And the other one is just a little bit of dilution happening, where some of the sewage that's actually in the water is being diluted, and therefore it's not so concentrated, meaning the bacteria would go down and the dissolved oxygen levels might come back up again. This slide is talking very clearly about how the variety and numbers of organisms are different in clean water versus degraded water, or water that probably has sewage in it. So here is clean water. It's got lots of vertebrae in lower numbers, but lots of variety. And then we add the sewage into the water, and all of a sudden, the variety decreases dramatically, but the numbers of the ones that are left increase a lot. So if you were taking a sample from a lake and all you found were 30 leeches and nothing else, you might conclude that water isn't so healthy because you're just seeing one variety, but quite a few of them. And then again, over time, water will recover largely because probably the bacteria have decomposed the sewage, and that will allow dissolved oxygen levels to come up, which will allow for a nice variety of living things again. This slide is simply saying that humans cause a lot of the water issues that we have. And so if you look at all of these pictures, you can see examples of how humans can impact water quality. Here you see a description of oligotrophic lakes versus eutrophic lakes. So those are two terms you need to know, page 115 in your textbook. And if you take a look here, you can see some of the qualities of an oligotrophic lake, some of the qualities of a eutrophic lake. An example of a oligotrophic lake might be something like Lake Okanagan, and a eutrophic lake would be something like Pigeon Lake here in Alberta. Eutrophication is the name given to the changing of a lake from an oligotrophic lake to a eutrophic lake, but it's mostly about gaining of nutrients. So when a lake starts to gain nutrients, it starts to eutrophy. And down here we kind of pulled a couple of ideas there. The term eutrophic means well-nourished, maybe too well-nourished in the case of a lake that's eutrophying. Eutrophication is the process by which a body of water acquires a higher concentration of nutrients, especially phosphates and nitrates. Here is a picture found on page 116 of your textbook, and it just shows how a lake might eutrophy over time. So the top lake is very oligotrophic. The second lake is, that lake is now starting to eutrophy, so you can see things like the temperature is increasing, the oxygen levels are starting to decrease, the water depth is starting to decrease. And then this last picture would show a lake that is pretty much completely eutrophied. It has turned into quite a different ecosystem than the original lake. The last thing we did was just look at a article from the Edmonton Journal, and it simply is showing that fish are dying in Lake Isle, largely because of the lack of oxygen levels, and in this one it was an algal bloom that created it, but it just shows you know, a lake that's largely undergoing eutrophication. Answer question number 5 on page 122 to check your understanding for this topic.